that don't know me, I've just got a short intro to introduce the session and welcome you all. So I work for AWS, Amazon Web Services. I'm industrial IoT go-to-market specialist, which is a lot of words, but I sit in the worldwide specialist organization. So my focus is on supporting manufacturing customers get started on their cloud journey, specifically around IoT technologies that can help your businesses. So again, refresher, this is the first of a series of events. There will be another in May, another in September, another in December around different use cases for manufacturing customers. And like we said just a second ago, I want to thank the SEC for today and for this whole series. But also do let us know if you have any thoughts, feedback, suggestions, ideas. We'd be happy to hear them. So for those of you that are wondering why AWS are here, obviously I wanted to just introduce as to why AWS for manufacturing, and my colleague Henry will go into more detail on this. But all of the obviously Amazon.com, the fulfillment centers, the logistics, the operations, all of that good stuff that goes on worldwide. The backbone of that is Amazon Web Services technology. We've got various different services and solutions and partners that we work with and use our own technologies that we then apply to benefit other customers. So yeah, again, Henry's going to go into a bit more detail, but I wanted to just introduce, for those of you that are new to your cloud journey and are thinking, what's she talking about already? There's plenty that we work with customers on, regardless of where you are in terms of your digital innovation transformation. And I'd be happy to work with you on exactly where to get started or what things mean and how to support you there. Common workloads we see for manufacturers. These are sort of the 5 pillars of activity that we see that are most relevant for manufacturing customers. Within that, you can see in the drop down, there's use cases. Some of these may be more relevant to you and your businesses and your challenges. Some of them maybe not. But this is just a summary of all the ways that AWS and our technologies can support your manufacturing processes and operations. So I obviously sit in the Internet of Things team, and I wanted to, again, just highlight the fact that regardless of where you are on your journey or what your requirements might be, AWS can support you. So we have over 200 different services in terms of cloud, which we call the building blocks that you can build your own IoT solution, utilizing all of the security that we have with those building block services. There's also purpose-built services specifically created for industrial companies like yourselves. For example, AWS IoT TwinMaker and AWS IoT Sitewise to help you collect, manage, store, analyze your data from your factory floor. And we have turnkey solutions. So this is how we work end-to-end with partners to have that sort of end-to-end story for your any projects that you have. As I said, we've got a huge, one of the benefits of working with Amazon is that you can leverage all of our worldwide partners rather than trying to navigate these yourselves and build your own relationships. You can leverage what we already have. So today you'll hear from Green Custard. Jonathan's in the room, and you can also see their logo on the slide as an example of a regional systems integrator that we work with. We also have hardware partners and software partners and everything in between, so that wherever you are on that journey, in terms of build versus buy, you can leverage all of these different logos to support you. So I wanted to end with top 5 tips. So you are all experts in your businesses and your manufacturing and your operations, but where I am an expert is delivering IoT projects to benefit companies like yourselves. And from my years of experience, these are the top 5 tips, and I want you to go through this morning's session with these in mind, so that at the end of the day we can discuss exactly where to start. So number 1 is focus on driving towards your business outcomes. At Amazon, we call this working backwards. So we start from what your customers need in terms of the longer term plan and how you're going to benefit, unlock new revenue streams, where do you need to improve operations, and having that as the starting point of your projects means that these will sort of last the longer term. Number two, consider where you fall between customization and turnkey solutions. Again, going back to build versus buy, you need to fully assess your business and your organization. Linking to point number three, if you have the in-house expertise and resources longer term to both build and manage long-term an IoT platform, or whether you need to work with a partner or the likes of AWS. If you're not sure where you sit, I'd be happy to discuss with you so we can figure out exactly what the most relevant place to start might be for you. But full evaluation needs to happen in terms of where your readiness lies. 4 and 5 are linked as well. Design for security from the start and build for the long term. As I say, these projects, this doesn't mean start massive and start from a huge project that would take a long time. We can totally help you to start small, but thinking about that long term and linking back to number one of that end customer outcome from that starting point means that you're more likely to be successful in anything that you implement with AWS. As I said, sometimes feedback that we get from manufacturers is, that's great, cool technologies, but I don't know where to start. AWS has a library of Kickstarter offerings that can help you get started on a small scale. We call it fixed price, fixed scope, which does what it says on the tin. For a quick pilot, you can, in a set amount of time, you can work with AWS and our partners to scale quickly and start in a safe sort of experimental phase. Green Custard, for example, are a partner that we work with on offerings like this, and Jonathan's going to walk you through their offering. But if you're already thinking, I'd like to get started, I'm not sure how, you can leverage AWS's existing library of partner solutions and offerings that can hopefully benefit you in the challenges that you're having. So that was a very quick whistle-stop tour from me, and welcome. But if you have any questions or anything I've said resonates, please come find me in the break, or that's my email and LinkedIn if you wanted to reach out there. Like I say, feedback always welcome on this session, or if you have ideas for the next roundtables. But I will hand over to my colleague Henry, who will go into a bit more detail about AWS and manufacturing.
So great. Thanks, Hannah. So good morning, everyone, again. My name is Henry Bob Manuel from AWS as well, Amazon Web Services, and I'm EMEA Industrial Accounts BD leader, BD for Business Development. Today, I want to also have a conversation about data, industrial data. And my view of data is that for the longest time, it's always been very important for manufacturers to manage their data and exploit their data. But something is happening today. We're seeing data has become really, really big deal. And to have that conversation, I put together an agenda so that we have a bit of structure. So initially talking through some trends, some of the challenges the manufacturers face in leveraging their data. And then I'll talk you through a concept and a solution we call the industrial data platform, a solution that we think can help manufacturers, basically address their data challenges. And then we want to run, it wouldn't be Amazon if we don't talk about customers. So some customer examples where we've actually leveraged the industrial data platform to help customers who exploit their data to drive outcomes, like Hannah has mentioned. We always work backwards from our customer. What is our customer trying to achieve? And what are those business outcomes that you want to achieve? And then at the end, a bit of a summary and then some Q&A. So let's dive right in. I'll start like this. Data is the new oil. Show of hands. Is that familiar? Is that phrase familiar to anyone here? So, I mean, it's about 50% of us. So, data is the new oil. Interestingly, I used to work in oil and gas. But I know that when you hear that phrase, for me, that says one thing. That says that there's value in data because oil is considered very valuable. Right now, in the climate that we're in, a lot of us would blame what's happening with oil price and the energy crisis and when we think about it, then it means that data is an asset then, if we're beginning to look at the value of data. But I argue it's not just any other asset. My argument is that it's a unique kind of asset, data. It's not your typical, should I say, asset. Why do I say this? I say because think about ownership of data. You can have access to data and you can transfer that access to someone and still retain access to the data. We generate quite a bit of data. It's the one asset I would say that while you're utilizing it, you're generating a lot more of it. And that's data. So data is quite unique. It's not your typical asset. So follow me on this journey as we just talk about it for a moment. So it's a unique asset. We say it's like oil, but is it really like oil? Is it really like oil? Think about it for a second. Maybe data is like water because we have it in abundance. We have a lot more of data. We're generating like a lot of it. And like water, if you're generating lots of data, you need to have the tools to navigate it. So you need to have the infrastructure as well. Think about flooding. When you don't have the right infrastructure, and then you have that surge of water coming through. Flooding, that's when flooding occurs. Same thing with data and manufacturing. You have a flood of data coming through. If you don't have the right infrastructure, the right governance, you're not able to exploit that data. Then you have unintended consequences. You have outcomes that are not desired. So that's just one thought there. The other thought to think about is this concept of data-driven organizations. We hear a lot about it today. Organizations that guide their businesses with data. They make decisions based on what the insights from data are telling them. I mean, there are many studies that say data-driven organizations are more likely to succeed, particularly in climates where, like now, difficult, sort of climates like now. But interesting thing is, manufacturing has always had data. In fact, one fact that we have is manufacturing, according to McKinsey, manufacturing generates the most amount of data by any other sector. Or in 2010, there was a study out, and it's not even close. The closest other is government. Think about government. Government holds all of our data, but still behind manufacturing. So why become a data-driven organization if you're in manufacturing? You already have that data. You have data in abundance. Perhaps that's a place to play because you have use cases you want to implement. You have lots of outcomes you want to achieve. The reason, this is some examples of benefits that have been well documented in terms of data-driven organizations. They make better decisions faster, respond better to your unexpected. What about the efficiency? Data-driven organizations are proven to improve their efficiency because they're using the insights from the data. So all of this, this is, if you think about it, this is common sense, sort of arguments put out there. But when we think about it, with the wealth of data that is coming through in manufacturing, all of that data, that's what, 1,812 petabytes of data. This is at 2010. Analysts believe that has grown exponentially today. It means that we're sitting on a lot of data. So manufacturing is data rich. So when you have all that data, how do we exploit it? So there is one way we want to exploit it if it's smart manufacturing. Smart manufacturing basically is talking about how you can begin to connect up your assets from the shop floor to the top floor, taking access of the data that you have and begin to use that to run insights that will help you drive, whether it be your factory operation, whether it be your supply chain, whether it be around your maintenance, whether it be around engineering and design. The idea is that you have access to data that you can actually liberate insights from to transform your business or your operations. So at Amazon, we have what we call a flywheel. We have our manufacturing data flywheel. And what this is, basically, it looks at three aspects of the end-to-end manufacturing process. So we're looking at the factory, we're looking at the product, and we're looking at engineering and design. Typically, you start at engineering and design. You design whatever it is, the product that you want to manufacture. So you design it, you put it out to be manufactured. So today, feedback loops control how we actually improve the end-to-end process. So if you think about smart manufacturing, where we have access to all of the data coming through, a manufacturer will say, I'm very interested in my OEE figures, my overall equipment effectiveness. What's that telling me? What's my quality doing? What's the uptime? What's the yield? You have all of that, those KPIs that you're working to. And as you begin to optimize your processes, you're getting feedback. And that spits out a product. The product is now used by end users, customers. They give feedback. We have things like NPS scores. We have, you have feedback that you give. If you buy something, for example, from Amazon, you go back and give a feedback. Oh, this product doesn't perform the way it should perform. You give some suggestions. All of that data is fed back into the engineering and design. So you redesign the product. In some cases, you get software updates, improving the product. So the idea is that this flywheel continues to spin. And ultimately, we help our customers to be more cost optimized. We help our customers to actually realize better outcomes for sustainability. So to keep that data flywheel spinning, one of the things that we talk about is when you start your smart manufacturing or your digital transformation, should I say, journey, what's really happening today? Think about what's happening today. Going back to our friends in McKinsey and other, consulting companies, some of the stats they're giving us gives us guidance. So what's happened in history? So most recently, about 70% of organizations in manufacturing are going into smart manufacturing projects. So digital transformation projects, 70%. That's a huge number. So if you're not already there, you're perhaps thinking about some kind of digital transformation project. But of that number, only a third are realizing business value. In any exam, if you was to score 30%, that's not a good path. That's not a pass mark. And why is that happening? About over 40%, about 50%, they attribute that to data integration issues. Pilot purgatory, as we call it. Hannah talked about pilots. The idea of a pilot is that you carry out the pilot to showcase the efficacy of the technology or to prove that this works. Then you take it out and you scale it. You take it into your plant and you mass produce or you actually implement. That's where you see real business value. But when your pilots are not being scaled, then it is a challenge. So this is what analysts have told us. We're not able to scale. And one of the reasons, because we don't have perhaps the right tools for the data. Now, what's the prize when you do a digital transformation or a smart manufacturing project? The prize there is that you want to be able to, number one, you have access to data locally. You put that data to work. So in a plant, let's think about kinds of things you're looking for. You want to be able to have dashboarding capabilities. You want to have predictive maintenance. You want to have some analytics. All of these capabilities you want to build. You want to be able to use data locally. And also you want to have access to data globally. So you're working for an organization that has plants all over the world. The ability to just go on your machine or your PC, access the data, carry out the required, sort of analysis to effect the use case. That's what you're trying to do. And data is available all over. So the organization has a mindset that there is data accessible. You come in and there are no silos. The issue of, oh, I can't access that data. I cannot do my analysis because some data sits in IT, some data sits in OT. And then there's this IT, OT, sort of issues. That's not what we want. What we want is an environment where data is seen as an organizational asset. So that is the prize we're after. But in reality, that's not the case. In reality, there are lots of deployment pitfalls. We have challenges with implementing from one site to the other. You have a situation where you go to a site, you implement at one site, then the rebuild seems like you're building all over again. The idea is you're supposed to be able to take one build and templatize it and then basically scale. But that's not what's happening. That's cost prohibitive. So the idea that you start a project and then you have to rebuild over and over again, that's not quite good. But this is what we're seeing. Then we have the IT-OT divide I spoke about. So these are some of the limitations that we're seeing today in terms of deployment. So to summarize in terms of the challenges that we see, there are like a number of challenges. One is we cannot access data because perhaps it's a legacy equipment, manufacturing 15, 20 years old equipment, there's data sitting there. How do you extract that data? That's one challenge. Different protocols. One is speaking Modbus. The other one is speaking a different, should I say, protocol. How do you communicate? Then you have the scale, the mass. Think about all of that structured and unstructured data. How do you manage that flood of data we talked about? Do you have the right infrastructure? This is where perhaps the cloud comes to its own. Think about the compute capacity that is available in the cloud. This is one area where a lot of manufacturers are beginning to think about the cloud as an option, because you don't have the server capacity, on premise to actually deal with that amount of data. So data management is an issue. So scale, what about a fleet of assets? You're dealing with today maybe one or two assets, but when you have 15, 20 assets and you have to actually begin to manage that fleet, that's a big challenge as well. Security for us is job zero at AWS and many manufacturers. With cybersecurity threats out there today, you have to be seen to be playing to that, but it's not cheap and it's not easy. The technologies are improving day on day, and also the cyber threats that are out there. So how do you keep on top of that in terms of security? When putting all of that together, the challenge as well is with decision making. We have the data, we analyze the data, the ability to put that data to work in near real time to get some actionable insights. So these are the challenges that our manufacturers face. So I've painted a picture that is very, very dire. Sorry for taking you through that journey, but now let's look at what a solution looks like. This is where we come up with what we call the industrial data platform. The industrial data platform is, this is an AWS well-architected environment, virtual environment that allows for connectivity of your assets, your industrial assets and data from the edge to the cloud. It's leveraging quite a number of, should I say, assets, from partner assets to AWS services in order to make that connectivity happen. The industrial data platform allows you to break away those silos that exist in terms of your industrial data. It also allows you to leverage insights from technologies like AI, ML, artificial intelligence, machine learning, the ability to liberate data sitting in your sensors, whether it be IoT sensors or legacy manufacturing equipment. So basically, end to end, it gives you the ability to basically aggregate data into a central repository. And it provides a solution framework for you to collect, store, and analyze your data. And finally, to act on your data as well. So this is what it is, and it comes with lots of benefits. The idea is that you could then begin to deploy, whether it be production and asset optimization, all the way down to sustainability, depending on what you are looking to achieve. The industrial data platform allows you then to carry out those use cases. So this is a different view, just to give you an idea of what it's all about. So right at the edge, you have the IT/OT data sources. They may be coming from different areas of your plant. Data ingestion is built in using some shop floor and other services. Just connectivity right at the edge. It could be leveraging some IoT device. But then in the cloud, you have a data management engine, which includes your data lake. And then you also have insights generated when you're using different types of models. So in a nutshell, that all comes together to provide you business applications that help you drive a number of use cases. And on top of that, we're building the security. We're also building DevOps to allow with continuous iteration and improvements, and MLOps as well. This gives you a stack, an idea of some of the capabilities that are available within the industrial data platform. So if you look at on there, you have also some third-party applications on there. And in terms of at the top layer there, so this could be production and asset optimization, energy optimization, so a number of business applications that you can leverage basically as part of it. So think about the use cases. So this is a list of use cases. So all the way from engineering and design down to manufacturing operations. So if you're looking at things like for sustainability, for example, if you want to reduce your carbon footprint, if you're looking at track and trace for supply chain, cycle time is an important one. You can monitor your cycle time. So there's a number of use cases that you enable using the IDP. So how do you start if you want to make use of the IDP? How do you start? How do you get started? We say start with your use case. What is it that's important for your operation? Is it around smart manufacturing? Is it around inspections? The idea is that your use case will determine what you want to put in place in terms of data sets, and you can work backwards from that use case. So it could be a case you want to monitor or improve safety. The idea is you then begin to look at the data assets that you need to assemble to make that use case work. So you don't have to start with a big bang. You can start small based on any of the buckets that you see there. And then this is what a stack looks like. So the collect layer there, you see that there shows some of the services from AWS. I'm not going to go through all of those. I know some of you are new to AWS here, but you have services there that allow you to leverage, allow you to collect and ingest data from different aspects of your plant. Then at the store layer as well, you have the infrastructure layer, you have also ETL and other third-party data services as well. All the way to the analyze layer, where you have quite a number of services that allow you to analyze that data and also bring things like machine learning to give you the predictive analytics to actually help you to drive what you see on the acts there, which basically is how the stack looks like. So again, another view, we leverage also a lot of partner assets for this as well. So in the future, what we see is, if you haven't deployed an IDP, we see a future that looks a bit different from what it is today. So that's the ISA 95 pyramid. Any of you recognize that? This is typically when you look at from the sensor actuator all the way to the management level. This is what it looks like today. And what this breeds is lots of data silos. Data silos, it means that you're not able to actually connect, for example, data coming through from PLCs, match that with MES. It's not easy to do. It's designed to promote data silos, lots of disparate protocols, like I mentioned before. But today, we're beginning to, with the IDP, beginning to leverage, we're bringing IT and OT together, leveraging protocols like OPC UA. We're seeing there, we're beginning to leverage some of the, should I say, plant assets like your PLM, your ERP, or CRM. We're bringing things like machine learning into the mix and creating a lot more of integration, which is very important if we want to deliver on some of the outcomes that we are pushing. In the future, what we are pushing for is what we call any-to-any communication, a real smart factory where you can have a robot talking straight, connected straight to the cloud. Insights from the data is used to drive a lot of improvements and transformation on your site. And you're seeing real data transparency around your operations. So let's talk about some of the successes that we've had. I'm not going to go in deep on this, but we can always connect after this in terms of the successes. So I'll start with Georgia Pacific. Georgia Pacific, they're wood products, pulp and paper organization. So they make lots of paper products. They have a number of assets, a number of paper mills, and they had a problem. The problem they had was they had, in paper making, they had converting lines. And those converting lines, as your paper is produced, they were having lots of cuts on their paper lines. Those cuts meant that there were lots of stops to their production, and it was costing them a lot of downtime. Now, if you're in the paper business, profitability, the margins are very thin. Profitability is depending on how well you can run the plant without those, should I say, disruptions. So they spoke with us at AWS, and we helped them with the Amazon SageMaker, which is an artificial intelligence and machine learning service, to help them to build a model that allows them to predict in near real time and predict way in advance when those tears are likely to occur. And we could predict all the way 60 to 90 days in advance. Imagine you having 60 to 90 days warning of an abnormal situation happening. And that is what we were able to do with Georgia Pacific. What that led to was they were able to run their plant in a more predictable manner, reduce those tears, and also improve the quality of their products. Steve Bacala, their VP of IT and Digital Transformation, he's talked about how they're using AWS analysis in terms of data analysis to improve their profits. Millions of dollars, he said, they saved on just one production line. Just think about what that would mean for 5, 6, 10, production lines. Again, this is using data to predict better outcomes for quality and maintenance. Coca-Cola, another brand that I think most of us know. Coca-Cola İçecek, based in Turkey, 400 million customers, basically, in a year. They had a similar problem as well. In their own case, when you know the bottling industry, it's highly regulated. And here, the challenge they had was that they couldn't determine when their clean in place lines were clean, really properly clean. They were operating manually. So what that meant basically was that they would expend a lot of water, a lot of steam to flush the lines because they needed to ensure that the lines were clean, really clean, before they could then get the tick to certify that, yes, they were operating safely and as the way they should. The challenge with them was they were doing this manually. So they couldn't in real time determine when their CIP lines, the sanitation lines were clean. They came to AWS thinking about how they could put in place some kind of a digital twin, which is a digital representation of the physical plant and the process. So we helped them here. We used a service called AWS IoT Sitewise and GreenGuards, which are some of our machine learning capabilities. And they were able to determine when those lines were clean. What that meant for them was that they were able to then stop dosing the lines of steam and water, saving them 20% annually in energy costs, 34 man-days of process time. Think about it. That's over a month of process time saved, because now they have the data that tells them operationally our lines were clean. And then water, 9% saving. So it's a huge sustainability benefit. But again, this is where you leverage data to basically drive operations as well. So 2 examples I'm giving more around the operations side. What about big transformations? It doesn't get bigger than Volkswagen. At Volkswagen, they think about it, the massive scale of operations, 125 plants, 10 million machines they had, lots of legacy. They had an ambition, an aspiration to connect up a lot of their facilities. They had partners and suppliers, about 30,000 of those. The ability to connect up all of that infrastructure, all of that end-to-end supply chain. Why? Because they wanted to get insights from their data. And what Volkswagen did basically was that they looked at their challenges. They said, look, we want to improve quality, we want to improve, reduce unplanned downtime. So let's get the data coming through from all of these assets and use that data to drive both innovation, change the culture and how we operate. And they had, the prize for them here was 30% of production efficiency. That is what they stood to gain. They worked with AWS to deliver this. So Dr. Martin Hoffman, in 2019, at our reInvent presentation, he mentioned a few keywords that I just want to highlight. He said, we chose AWS not only because of the technology, but because of the ability to scale. Think about that massive scale in terms of data to provide us the standards for our factories. And speed, he talked about implementation speed as well. So the speed, a project like this would normally take years to implement. Working with Volkswagen, we did it in record time. So this is where Martin Hoffman also acknowledged the speed. But just think about Volkswagen, the big beast of an organization, transforming their business basically with data, aggregating data from different aspects of operation. So in summary, there are 3 aspects to what I would basically advise here. One is around data-driven organizations. To become a data-driven organization, I mean, it starts with you acknowledging the fact that you want to use data to drive your decision-making, improve your operation, and also transformation. Work backwards from your use cases. Similar to what Hannah's mentioned, where you have an outcome you're looking to achieve. How do you get to that outcome? We work backwards. Data is our friend here. And in your organization, look to also democratize access to that data. Let's have data begin to work for us and let that data be accessible. In terms of investments, yes, obviously we would say invest in some kind of a scalable, integrated sort of IDP, that's the industrial data platform, where you can leverage a number of the technologies that we use for smart manufacturing. But ultimately, the idea is that you will realize, some ROI alignment, and hopefully you're not amongst the 30% that we talked about. We want to improve that 30%. Let's get it up there to about 70 to 80%. Let's get more people, a lot more manufacturers to be successful in their digital transformation journeys. So think big, yes, think big, but start small. We can help you also to scale fast as well. So that's where I'll end it. And thank you very much. Any questions? Happy to take. Yeah.
Really enjoyed the presentation. It seems like there's a lot of commonalities between general software projects like migrating to the cloud and presented here, but the devil in the detail to avoid getting trapped in that 40% of pilot purgatory. What are strategies that you can envisage for minimizing that risk, I guess? Yeah,
I mean, it starts very much in understanding what is it that you're trying to achieve and what are the, should I say, the inputs required to get there. So I would take it, the way I would answer this is very simple. If we have a project that we want to implement, what is the end goal? Sometimes you will find, oh, we want to do a project, we want to start. We don't want to think just about the implementation of that little project as a small spot project. Think, what will be the implications if we scale this? That's important. And then begin to look at, do you have the data sets required for that to happen? Now, we at AWS, we believe very much in helping you build, but also we also believe in partners, using partner solutions as well. So the ability to use the best of breed solutions. So leveraging whether it be AWS or whether it be partner solutions, but ultimately keep in mind the use case and keep in mind the idea that you might implement something small today, not a problem. But once you start to scale it, are you prepared to scale that? And if you think about that, then you will be architecting it right. So getting the right architect in right, that's important. And then think about the long-term vision of, if that is successful and you want to actually scale it, is there going to be constraints in the way you've architected it? This is where I would think these are things you think about. But then very important to ensure that you have the right data sources of support. And also, do you have the right governance in terms of data? Sometimes data could be, you work in a system where the data is not easily accessible, or you don't have the data in the right fashion. So some of the things you want to think about before you start. And then hopefully, if you architect it right, if you ensure that you have the right governance, and you think more long-term about how that could go, you give yourself a good chance of success, really.
Yeah. I'll just add something to that, because there's you mentioned McKinsey. So McKinsey got some really good stuff on the internet about lighthouse factories. So they've got a whole load of factories around the world, which kind of best in class. They're doing all this kind of stuff. They're combining automation, data, and sustainability with bringing people on. And they talk about the pilot purgatory. And in there, they discuss how this is got very data driven. There's like the human element that's required. So it's sort of some of the challenges with the teams and how you set up a team to deliver these projects so they don't get stuck in pilot purgatory. So there's a big human change element to this that they're kind of.
And then there's also the reality with your shop floor, right? So obviously for Volkswagen, they're able to buy hundreds of the same machines. So if they get the software working for one, then they can roll it out. But you might have 4 different CNC machines for over a variety of time scales. And then that's a lot of bespoke work to actually ingest that data. So you might have all the will and the ultra mindset to do it, but the practicalities of being like, all right, have to write however much just
One advice that I would say, there's nothing you could, there's no, I mean, you need to have, number one, the right tool, the right job. That's important. So there's situations where you look at it and you will say, okay, the people element can be a challenge as well. But let's have the conversation around, where are you going with this? I've seen projects that started small, and before you know it, typical project mentality, oh, maybe we'll add this to it, maybe we'll do this to it. Before you know, that begins to grow and grow, and then it's not fit for purpose. It's not architected right. So then performance, you begin to see some of those challenges. But if you build with a mindset that ultimately, if you architect it right and you have we call the industrial data platform a solution framework. It's not a product you can just go and buy off the shelf, but it's a mindset that, okay, you have applications that you can leverage that allow you to collect and ingest the data, those that allow you to store the data. You can leverage, like for us, it could be a lake formation, sort of allow you to get the right data lake. And then you're looking at analysis. What are the tools? So we typically would say, use the right tool for the job. That way you're more efficient. And then in terms of scalability, then it's easier as well to scale. But then again, it's around, be very clear, what is the objective you're out for? If that objective is well defined, then you don't have the challenge of, you don't have that problem going forward. You just, once you've achieved your use case and your outcomes, then you're good.
Just another, I mean, there is a huge opportunity for legacy machinery out there. So it's about starting those projects and understanding, I guess. One of the things we do is retrofit sensors into a standard set of sensors and a standard set of parameters and controls into legacy machines, and try and standardize around a few groups of that, but kind of overlay on top of what's already there with a little bit of interface in it.
Retrofit a sensor that some PLCs you'll just go hit data out of fairly straightforwardly. So sort of partner. I think we have partners who, there's a case study I talk about where they connect up. I think there's hundreds of CNC machines of all different varieties. So yeah, it's definitely achievable. But it's, it all comes down to what you're trying to achieve with what you do.
Yes. So any other questions? Any comments? Maybe? Okay. Thank you. Happy to catch me. I'm still around. We can have a chat. Yeah. Cheers.
We've got a short break now. Yeah. Yes, thank you very much, Henry. We're actually running a bit ahead of schedule, so we've got an extra 10 minutes for a longer networking break. So we'll see you back at 11:30.
That's magic. I don't know who presses that. It must be a remote control from over there. I did wonder how it keeps starting magically. So thanks very much to STC and AWS for inviting us along today to talk to you. And we're going to be talking about manufacturing with AWS and IoT. So who am I? My name is Jonathan Custon. So I think I've met most of you now. I'm one of the directors and owners at Green Custard. I've been in the software industry for almost 30 years. So yeah, quite a long time. I'm the IoT practice lead at Green Custard, and I'm also one of the sustainability champions. So really focusing on how we can work on sustainability within the organisation. So I'll touch on that a little bit as well. So a little bit about us. So we are an AWS partner. We are an IoT specialist. Ultimately we're a professional software services company doing a lot of system integration work, and we work exclusively on AWS. We don't work with any other cloud partners. And we have projects that sort of can be things like working on complete new IoT projects for people. It can be retrofitting IoT to create new products, or retrofitting IoT in manufacturing environments. We kind of work on a number of different areas. So areas that we work in include smart manufacturing, smart buildings, distribution of supply chain problems, and also industrial application initiatives with things like utilities. We're based in Cambridge. We've worked on projects all over the world. So US, some in the Nordics, and quite a lot in the UK. Our current NPS score is 9.7, which is something we're incredibly proud of. So we have a customer success team that helps and sits alongside all the projects that we run. And, that's something we're very proud of. And I think there's a quote there from Martin Engineering, which sort of talks about, they view us as a really good example of business partner. And we kind of view how we work with customers as a partnership. It has to be something that is good for them, and it's going to deliver some value to them and their customers in order for it to be successful. So just a little touch on just kind of our sustainability journey. So we kind of thought last year that we should really start doing something about this. Obviously, I think we're probably amongst the sort of most companies that are starting to do something about it versus those people that perhaps leading it several years before. And probably one of the first things we wanted to look at was kind of, what is our CO2 emissions? And so we had a look at that. So I don't know how familiar people are, but tier one is sort of generation. So, gas burners, those sorts of things. We don't really do any of that. There is some we have, HVAC, and we have fridges. So that does count because you can get leakage and emissions from those. But it's such a tiny percentage that it kind of really has limited applicability for us. So in terms of tier two, which is sort of basically electricity use, that's actually quite hard. So a bit like this, we're in a shared office building. So power is common between buildings. So how do you measure your power? Because you can't really measure it at source for you. So we kind of switched to per plug monitoring. So get a really good understanding of the usage there. We have strip lights, and it's quite hard to get the wiring for those as well, but actually we can put light sensors, and therefore we can identify when a group of strip lights is on, and from that get a max power that's being used for those strip lights. So that's a good way to measure that. And obviously we can put clamps around HVAC and things to sort of measure the power that's being used there. So that gives us a really good understanding of that tier two usage. And for tier three, we use something called Ecology Zero. Ecology Zero is a tool which basically hoovers data out of your accounting system, looks at all of the transactions that you're using. And from that, it it basically allocates a cost per industry that you're kind of working with, and gives really good information on that. And so that's really powerful. And then kind of we're using ecology to kind of offset that. So ecology, the way that they sort of give you calculate the amount of CO2 that you're offsetting is by certified funded projects. So an example there might be avoiding methane emissions in Brazil, or it might be wind generation. So trees are not counted as part of that. They also plant trees on our behalf, and that's kind of viewed as a future credit, because obviously they're saplings at the moment. They're not really doing anything. So the really important thing is those projects that they fund. We've also got some goals for 2023. So we want to try and reduce CO2 per person by 15% per employee. That's kind of our initial target. That's offering whenever we think we can achieve this year. Will we hope to. We might exceed it, but that's kind of our target. In addition, we're looking to sort of donate 1% of our profit and time to local causes. So that's a bit about our sustainability, because sustainability is a slight factor within smart manufacturing. So let's talk about business change and IoT. And there's quite a good quote from Albert Einstein: "The world as we have created it is a process of our thinking. It cannot be changed without changing our thinking." And that kind of really sums up that, you know, to innovate and to do something different, you do sometimes need to think differently. And I just want to touch on sort of what IoT means to us as Green Custard. And fundamentally, it's about improving businesses. And that nearly always starts in a similar way to AWS from what your customers need. And that's what it's fundamentally about. And in manufacturing, that's often cost reductions, resource savings, efficiency gains in order to save money. And but it can also be bringing completely new experiences to customers. So building new types of products or getting additional revenues from products after sale. So different ways of generating revenue. For sustainability, it can be about changing some of those behaviors, both inside the business, about how you view yourself, and also outside of the business. So either for your customers and your distribution, or into your supply chain. IoT has lots of other benefits. So, you know, it can be around health and safety, it can be around working environments, and there's got other examples that Henry had on his slides. And I think, you know, in terms of delivering solutions, for us, it means typically using smart technology, in quotes, to build solutions. And for us, IoT kind of means sensors, it means connectivity, it means machine learning, analytics, vision, robotics, apps, whatever you need to deliver a solution for a customer, depending on what their unique requirement is. And it can be any of those. So in terms of typical approaches, you know, it's fundamental to understand stakeholder and business needs, and ultimately customer needs. If you're going to help somebody do something with IoT, it's essential that you understand that and you get that right. And I think it's also really good to understand what's done today, what data exists today, what approaches are taken today, and really sort of understand, if you like, the baseline of what's happening. And then really, you know, it's about getting data or contextual data and information to explore that problem space and sort of get an understanding of, you know, what am I dealing with, and then, you know, quickly build outcomes to you know, deliver outcomes to stakeholders to sort of show that you can build value, and from there you can go forward. So it's kind of, you know, understand what can we deliver quickly, build something, get some value, show some purpose, and then scale. And sometimes for some customers it starts bigger. It's not always a small step. So I guess another question is why now? You know, IoT is certainly not new. Telecoms equipment, ATMs, a whole variety of equipment that's out there in the world is effectively IoT equipment that's been around for a long time. When I was at university, seemingly too many years ago now, there was a coffee pot that was connected to the internet, so you could see coffee levels and understand when it was the right time to go and get a drink. But I think some of the sort of factors around IoT have become really clear now. So the ROI arguments are much clearer. So cloud, AWS costs, very competitive, very low. Connectivity costs, Wi-Fi cellular, very low. Device prices, sensors, much lower in price than they were, you know, even a few years ago. Whereas on the other side of it, a number of things have gone up. Energy prices have gone up significantly. Staff and labour costs have gone up significantly. And with things like pandemic and Brexit, competition has become ever more increasingly, you know, a factor. And I think another area around that is kind of sustainability. So sustainability is being legislated. Consumers and customers are now making choices on what they buy based on, you know, that product, and is that supplier, you know, do they have good credentials from a sort of CSR capability? And also, it's hot out there, and not today, but, you know, last summer 42 or whatever it was in the UK is ridiculous. and really that means that we should all be doing something about that. And I think the other point is many manufacturers are innovating. There's a stat on the slides previously. Are you innovating, and what should you be doing? So I just want to talk on some of those typical sticking points that we see, which came up in previous presentation as well. And I'm not going to sort of address those now. I'll sort of come back to them later. But probably the first is that local and cloud security, is people's concerns around security, and that must be the primary job in IoT. That has to be right. The second one is around that cross-team collaboration. So you've got IT teams, you've got OT teams, you've got ops teams. If you're for a smaller business, you might not have those. If you're a larger business, you might have many departments, and also you might have multiple departments with multiple versions of those teams. And so collaboration is a really important thing, and sort of trying to get that going is important. There's a point about data ownership, which was mentioned. Data siloed in different systems is a problem. Making sure that people have access to that data and be able to actually use that for the purposes that they want is really important. I think sometimes people can have a barrier and a concern about the internal knowledge that their organisations have. Do they have the knowledge to take this forward and work with it? And that worry about external support. I think another factor is, okay, and this is sort of back to the sort of pilot purgatory. I've done something. How do I scale it and extend it? How is that possible? And again, another one is sort of equipment interoperability. Is I've got all these different pieces of equipment. How on earth can I connect all these different pieces of equipment? It's really complicated. And sort of kind of the final one is that caution to start, and that's either moving forward from that pilot, or it's just starting at all, and that sort of procrastination around starting. So that's something that we see. So a much simpler diagram of a typical manufacturing business, but I think IoT can apply in many places across the spectrum of a manufacturer, everywhere from the supply chain with things like automated fulfillment, anything in manufacturing such as predictive maintenance or energy management, into distribution, so real-time tracking of goods being distributed, and all the way through to the customer. So perhaps providing some remote monitoring of customers' products, improving their experience, or maybe automating something like consumable fulfillment. So IoT can kind of apply anywhere within that space. And it's really about what's the important use case for your business at this point to drive it forward, that you should focus on. So another thing that we kind of think about is kind of evolution versus revolution. Make UK did an interesting report. I think it was either 2020 or 21, talking about where businesses are, and are they, have they thought about IoT at all? Are they starting in IoT? Are they kind of evolutionarily using IoT, or actually are they revolutionarily using IoT? And their kind of goal is to get everyone to be revolutionarily using IoT to really sort of transform their businesses and do things differently. So evolution typically is where people might start. So this is looking at sort of typically fixed solutions and services, so kind of off-the-shelf things, and they're kind of around incremental innovation. So it could be things like that, preventing equipment failure, so by fitting sensors or getting some information to do that. It could be around increasing efficiency by sort of measuring performance, etc. And it can be around reducing energy and waste, so understanding how energy and waste are being used and looking at process to improve that. When it comes to sort of revolution, it tends to be more disruptive innovation, sort of innovation that startups might be doing. And we've kind of worked with quite a lot of startups and also with global organizations doing some of this innovation. And it tends to be sort of more bespoke solutions and services. And it's about increasing product value. So I'm not just selling a product now, I'm looking actually to sell services to my customers and get recurring revenue rather than that one-off product sale. It's about getting better after-sales service. And it's about kind of improving designs over time, getting better product market fit, getting a better product out there for customers. And projects will sit somewhere on that spectrum, and it could be anywhere on that spectrum from one end to the other. And I think that was something that was referenced by Henry as well. In terms of the success factors we've seen in projects that we have worked on, I think probably the biggest thing is people. And it's probably that alignment of stakeholders within the business behind a common goal. So there needs to be, we've worked with AWS on a number of working backwards engagements, and this is something that Henry touched on. This is where you're really thinking a few years out, you're thinking about what your customer needs. It doesn't have to be that far reaching, but you do really need to get that agreement within the stakeholders to sort of get a really efficient project moving forward. I think the other thing is try to look at reducing change on people and processes. Sometimes it is essential, but where you can minimize the change on people and processes, actually you'll get more traction quicker. And it might be that you can start with something that is a minimal change, you get trust, and then later you can introduce bigger changes, but people trust what you're doing. Other success factors that we see, I think owning the data that you generate is extremely important. It's important that you have that. You can do what you want with it, whether that's with a partner, with AWS, or with someone else, or you're on your own. If you want to build new capabilities to use that data, you should be able to do so. I think another thing is where you can, leveraging managed services. AWS have a lot of really great managed services, which means that you can get a lot of products and solutions going really quickly, and also making use of off-the-shelf hardware where possible. Again, this is not always possible, but if you can, it can reduce cost. And I think the other thing is that caution's getting started and sort of getting people over that. So really helping people to understand, okay, what challenge should I tackle, and how can I start small, iterate fast, and effectively be data driven in what I do. And I think that's really important in terms of those success factors. So the sort of final sort of note on this sort of introduction to sort of what we think about IoT and sort of business change is the fact that actually sustainability really does mean you're running your business properly. You know, they're kind of almost synonymous these days, particularly with the price of energy and various other things. Ultimately, sustainability is about doing more with less. So less waste. If you have less waste, you've probably got less cost for getting rid of that waste, and you've probably got less oversupply. If you're using less energy, then you're paying less for your energy bills. If you can increase your productivity, then it's likely that your performance per fixed amount of factory operation is lower. And greater uptime from things like predictive maintenance means that you're not going to be replacing machines as regularly, you're not going to be repairing machines as regularly. That's going to give you greater uptime and better benefits. And so all of those things are good and are great outcomes. But the other thing is it's starting to be expected from a customer perspective, both B2B and B2C, and it's also being legislated. I think all businesses over 250 people in the UK have to have a published plan for sustainability as of the end of 2023. I think it's something like that. I can't remember the exact details, but you can kind of look that up. But it is going to get more and more legislated. So I just want to touch now on evolutionary IoT, and we've worked with a number of customers in this space, and there's a quote there from Peter Lai at NGF Europe, which I'll let you read if you want to, and it's just sort of talking about that incremental innovation, and really it is about starting small and doing something additive to what you're doing at the moment in sort of manufacturing. And I've sort of talked about this. Those typical cases are that preventative equipment failure. So it's really about detecting problems early and preventing those catastrophic failures of pieces of equipment, which are so costly in terms of downtime and also in terms of repair costs, and sometimes even in finding parts, particularly if it's legacy equipment. And on the other side of that, it's about being able to repair on your schedule. It's about understanding what the condition of machines are and being able to actually do repairs when it suits you. There are industries where there might be regulated repair schedules, but in a lot of industries, you can actually run off your predictive maintenance schedule, and you can schedule when you choose to do that, when it suits your production and processes. The second area is sort of reducing energy and waste. So this is basically tracking energy and water and waste usage, which can be done relatively easily with some sensors. And from there, improving processes to reduce those. And obviously, if you've got that baseline, you can then see that improvement. And the final one is about increasing efficiency. So this might be monitoring ideally all of availability, performance and quality to get kind of OEE score and improving that over time. And we work with a lot of businesses that just don't have that data today. It's very hard for them to get some of those measures. So basically just giving some of those basic measures, baselining them, and enable them to improve over time is a really simple way to get started. In terms of preventing equipment failure, the most common types of equipment you often see in manufacturing are things like fans, pumps, motors, and other rotating equipment that play a huge role. And actually, it's relatively easy to start detecting problems and solving problems on those types of pieces of equipment. So, for example, vibration and temperature sensors can actually detect many of the problems that might be important in terms of that predictive and preventive maintenance issues. So vibration sensors measure certain acceleration and velocity measures, and they can effectively detect things like impacts, which could be things like fan blades being hit, which might detect that there's a potential problem coming. It can be things like fatigue, so misalignment of blades. It can be things like unbalance, so on things like fans or pumps, that can be a build-up of detritus on them. It can be friction, so that could be, previous damages causing a blade to drag, for example, or it could be bearing failures, cavitation. Then obviously temperature of the actual unit itself could be detecting things like loss of coolant. It could be to do with excessive load, or it could just be some electrical issue. And so you can get that immediate visibility from those measures, which can give you some very quick information about the health of those assets. And obviously in some factories, you might have hundreds of these assets. Any one of those going down could affect downtime. So being able to monitor those effectively is really important. And it's also really easy to start small with that by picking a subset of fans, pumps and motors that you might choose to use. You kind of get some side benefits as a result of this. You get some uptime monitoring because you can tell when they're in use, which can give you some insights into your factory uptime. Obviously, you can enable staff to do these checks remotely from wherever they choose to be. You obviously can get energy savings because obviously these products are running more efficiently, they're better maintained, and also hopefully you're having far fewer catastrophic failures, which means you're repairing and not replacing, which reduces cost. And over time, you may be able to build up really good information and data on these products, which gives you a really good way to build out models to do predictive maintenance schedules. There are obviously pieces of equipment that are far more complex than that. I was just mentioning to earlier, somebody there's a 5-axis or whatever it is CNC machine that we're working with the customer. I'm not an expert in CNC machines, but we have partners who are, and that's a really complex piece of machinery, and actually getting some knowledge and information on how that's working is complicated. And so we work with partners to kind of understand how that happens and how we can do that. Kind of the second area is kind of water and energy reduction. There's a couple of customer examples here, and sensors can really easily measure and report these usages. So we have a customer with a vinyl press bed. So these are basically big machines, heat lots of air, heat some vinyl, blow it down onto some doors and then seal it. So electricity cost of energy for those blowers and heaters is very high. It's expensive. Then also they notice the efficiency of the bed. So if you've got this bed and you're pressing these doors, they notice that sometimes there might be 2 doors on this bed, sometimes there might be 10 doors on this bed, and it all depends on what happens to be coming through the line and the order of which people happen to be doing things rather than actually thought about. So actually over time, by sort of monitoring how much that bed is occupied and what the energy of those blowers and heaters are, you can improve the CO2 per product. You can actually reduce the CO2 per product that's produced, and also you can overall reduce your energy cost. So it's a really effective and simple way to do some simple monitoring, which can really have an impact on the business. Second one was a contract PCB manufacturer working with who had solder baths, and their typical behavior was Monday morning, 8 o'clock, turn on solder baths. That's it. They're really, really high energy heaters. And so is it sensible to do that? Shouldn't you perhaps tie that to your production needs and actually maybe turn on those baths when they're needed? Maybe they're not needed on Friday afternoons. Maybe they're only needed, from 3 p.m. on a Monday. So actually, if you can actually turn on those solder baths when you need them, tied to your production needs and where you are in the process, then actually you can reduce a lot of energy cost from those solder baths. So again, something really simple. Another customer who was looking at basically waste of paint. So they basically make paint in bulk, and they make this for artists, and that bulk paint goes into pots and tubes. They get filled, they obviously then get packed, and they obviously get then sent to distribution. Now, once the current recipe is going, so let's for example, ERP system says we're making green paint now. So all the ingredients get mixed, that bulk paint gets made, gets put into those pots and tubes, and at the end of that, you've kind of got some waste, you've got some leftover. What do you do with it? Well, you have to get rid of that waste. You then have to clean it with water to clean out that system before it's the next job of paint to go through, which may be cobalt blue, whatever it might be, and then that will get made and manufactured. And so by starting to use a laser distance sensor sitting over kind of where the waste builds up, you can kind of get a measure of the waste from each of those runs of production and sort of correlate that back in the ERP system with the type of paint that's being produced. And from that, you can start to optimize the ingredients that are used and really sort of optimize that. And as a result of that, you reduce the amount you're throwing away. That's good. You reduce the amount of water you need for cleaning. That's good. But also you're reducing the amount that you're purchasing from your supply chain, which is reducing your tier 3 sustainability, and also meaning that you're not oversupplying. So actually, all round, it's a really good benefit. So just talking about one of the NGF Europe use cases, this is with the partner CloudRail, who's a gateway partner of ours. So NGF make glass cords. So these glass cords are dipped in latex, and they are incredibly strong, and they're one of the only producers in the world that can produce them to this strength. And they're used for things like car cam belts. And they kind of had a vision to do real-time monitoring of these dip baths. So they wanted to know what the state of them was, because occasionally they were just empty. People didn't notice, or they were low, or there was a failure. And so they really wanted to know when is that happening? And kind of the challenges where it's a lot of a legacy equipment. It's a very harsh environment, humid, lots of chemicals. But the product that ultimately needs to be produced needs to be very high quality. So how could they go about this? How could they get that level of quality and insurance? So again, this was very similar to the waste case. Laser sensors can be used to track the fill level of those latex baths. Very simple to do. And then from that, connect that via CloudWell Gateway into AWS. That produces very simple dashboards at the end of a line to show what the fill levels are and can provide alerts and notifications for people to go and address problems when they occur. And as a result of that, increase uptime. But very simple. So now I want to chat a bit about sort of revolutionary IoT. So this is far more disruptive. Another quote from one of our customers there, Martin Engineering, which I'll talk about a bit more in a minute. So disruptive innovation is kind of, doing something really different, and kind of typical use cases we see are that increasing a product value. So this is transitioning a product from a one-off product sale to something with a service revenue. So working with a customer at the moment that makes equipment to monitor air filters in factories, and they're basically working on some unique software that can do additional analysis of that data, which provides additional predictive maintenance information to their customers to sort of maintain those filters and things. And so they can get an additional revenue stream out of that, and an additional permanent contact with the customer for that solution they're providing, rather than in the past where they just sold something and occasionally someone would turn up from sales and see how they were doing. So it's a real big change. It also enables differentiation. If you're using software alongside a product that you're selling to a customer, you can differentiate it and change that product quite easily to charge different costs at different points for different feature sets. It can also be about better after-sales service. So if you have a product, if you're, say, a B2B customer supplying a product into the field, you can kind of look at preventative maintenance of that product and start to identify if that product needs repair and potentially automate that repair. And actually, there are some companies that are even going as far as saying, we provide a warranty on your product and we'll automatically repair it when it needs it, and we'll keep it running. And so there's, really different,
Okay. Apologies for that.
that's okay. People wonder why I'm switching between things. And so kind of the traditional way that drinks are made, very simplistic view, you have some bottles and cans, you mix some ingredients in manufacture, you put them in the bottles and cans. These products that we're typically working with at Britvic are for sort of offices or potentially retail environments. So you think about I think actually there's one in AWS, isn't that, in London? Yeah, in LHR 14. So businesses like Amazon have these taps, so distribution, they get all these products get sent out. So shipping lots of bottles and cans, that goes into bulk refrigeration in those venues. Obviously, there's a cost there. And then it's just drunk, and hopefully somebody's enjoyed it. But then what do they do with the bottle or the can? Hopefully they recycle it. They might not, they might chuck it. Who knows? It's kind of out of your control. So the whole Aqualibre concept is about starting with reusable cartridges. So drinks will get manufactured and placed into reusable cartridges. The concentration of those is 2,000 to 1, which is a massive, massive increase over sort of traditional sort of other soft drink dispensers. So there's a massive reduction in the distribution cost. There's no refrigeration of the drinks on arrival. Bear with me. These go into drinks dispensers, and so water is chilled as needed, and it's dispensed into bottles like this, and so there's no waste from that. So, you know, there's kind of a huge benefit there from a sustainability perspective. So the sort of energy for distribution costs are much lower. There's no energy for refrigeration costs. You're reusing the cartridges, and you're relying on people to bring their own bottle and not have single-use plastics. So that's a really positive thing. Kind of the benefits that they've got from working on this is they've been able to do really rapid product iteration, which we've supported them with. They're able to actually get real-time product insights. So if we think about a drinks manufacturer shipping products, they go into a distribution channel, someone buys it a long time later, no idea, nothing, but they can actually get real-time feedback on the drinks that they're dispensing. They can also do experimentation with flavors and again get feedback upon that. And also they've got that connection to the customer, and that enables them in the future to do really interesting things. So you can think about things like loyalty, personalization. So all of these things that are potentially possible. So from the customer benefits, so for the office installing this, there are also a whole series of benefits. They get very good after sales service. So obviously you can do things like automatic consumable replenishment. So cartridge is going to be empty, send a new one. They can get sustainability reports, which might give them an indication of, okay, well, how many bottles have we saved from being used, or how much CO2 have we saved as a result of the savings from having drinks in this manner. Obviously, that company isn't having to pay for fridges. They can take those out. They don't have to run them anymore. That's an energy saving. They also don't have to dispose of the waste that their employees might have had from having those drinks and chucking them. And ideally, staff are healthier as well because they're drinking sort of healthier flavoured drinks rather than less healthy flavoured drinks. So in all, it's a really good product and really fits with that strategy that they've got. Another customer we work with is Martin Engineering. So you can probably tell from that picture, they work in sort of bulk material handling. So their whole process is around making that sort of process safer, cleaner, and more productive. And they have a whole series of solutions across industries like mining, quarrying, and various other industries, cement making. And they make something called, one of their products is a belt cleaner. So if you imagine a conveyor belt, when it gets to the end, it sort of turns round, and you want to do something with all that material that gets stuck to the belt. So they kind of have this belt scraper that sits on there and scrapes that material off. And that, in doing so, that will save material, which saves cost, and it will also save machinery. And they kind of had this vision that they wanted to be able to give their customers greater uptime by providing guidance on that sort of maintenance, so they can actually detect vibrations and various other things that are going on that conveyor belt. They wanted to provide warnings on high temperatures, which might indicate there's a problem with the equipment. And they also wanted to be able to do things like predict when those blades that are doing that scraping need replacing, so they continue to do the job they're meant to do. And again, this was really challenging. So it's a global customer base. They've got customers in remote sites, so centre of Brazil, centre of Africa, centre of India, long way from airports, very harsh conditions, muddy, dusty, hot, humid. The kind of solution, it's kind of a global IoT solution with global SIM connectivity, automated deployment of their IoT solutions in the different regions that they were engaged in, kind of a centralized approach to sort of fleet management of all those devices, so they could see the health and what those devices were doing. And kind of alongside that, they developed a field service application, which enabled them for the people who are actually doing that service to have some really good guidance and insights into what they were doing. Kind of the benefits for their customer were kind of, increased uptime. Obviously, if that material is going back over a conveyor belt, it can wear out. If a conveyor belt breaks, that is a significant issue for a company that relies on conveyor belts to move products. It's also a huge reduction in wasted material. And it's actually improved safety. And this isn't something I knew, but something they told us. If you've got a conveyor belt with a whole load of equipment, traveling along it, and there's a big lump of rock or stone or rubble on it, it can fly off. That can hit somebody. That's a serious issue. So by excuse me, by ensuring that's scraped off, it increases safety as well. So yeah, that was a really interesting solution and project. So I just want to talk now about how we typically help people start. And I think it's a good Lewis Carroll quote there. In the end, we only regret the chances we didn't take, which I think is a nice way to think about it. And I think this has come up again and again in terms of, what you need to do is you need to identify an opportunity, something that's going to have benefit to a business. And the most common things we see when we're dealing with people on an evolutionary basis, which is often where they start, are about this preventing equipment failure to maintain uptime and also to avoid those critical equipment failures. And it is about, particularly at the moment with the cost of energy, about understanding and improving their energy use. And it is about that sort of measuring uptime, performance and quality. And I think when starting, it's really important to get all stakeholders involved. Make sure you've got that clean understanding between people in the business. It's really important to understand the data you've got today. So maybe you have equipment that fails today. Maybe you keep records of those failures. Maybe you keep information of when the uptime and downtime problems occur. Maybe you've got some reason codes that are saying why there were failures. That information is really useful. That can help you start get a baseline of what your performance is. For example, if you're looking at increasing uptime by preventing equipment failure. And from there, it's really about making decisions with data. So it's getting the right data that's relevant for the application or the problem that you're trying to solve, and then iterating using that data and keep improving. And that's really the simple way to start. And I think I'm assuming these slides will these slides be sent around? Yeah. So if these slides are distributed, I'm not going to go into all of these, but this just lists some really simple use cases, kind of the problem, the potential, and the really simple solution that you can use to solve that. So we talked about some of this. So obviously equipment failure and sort of spotting problems across multiple machines. Again, vibration and temperature sensors we talked about. We talked about waste and using laser measure sensors for sort of detecting fill levels and then getting audible warnings. There's also things like pressurized air and compressors. So pressurized air is expensive. Obviously, you've got to run compressors. Leaks are basically just a big cost sink. So obviously, if you can improve that, you're going to improve efficiency and you're going to sort of reduce your energy costs. And again, that can be done by simple things like pressure vibration sensors, which then enable you to get a really good understanding of the difference between something that's running well and something that's running poorly. You'll really see that stand out quite clearly and be able to address it. And you also have things like piece counting. So if you've got continuous manufacture of I don't know, small parts, quite often they go along a production line, go into a bin, get weighed. That's how many have been produced, but that isn't great for sort of continually optimizing your process flow. So why not have some laser counters which can detect when those parts are going past, count them as you go, and help do that optimization as you go. And again, that's really easy with things like laser counters. Build some really simple visualizations, put some feedback into your ERP systems, and really tweak things. So just some really simple use cases. So just to touch on a few use cases. So CNC machines came up. So a partner, Cloudrail, did some work with the multinational aerospace company, so about 270 facilities. They wanted to monitor hundreds of CNC machines, and they wanted basically to get notifications on breakdowns and stops. And kind of the biggest challenge was, there were all sorts of CNC machines of all different ages. They tried various DIY approaches in the past. They'd kind of not really worked. So how could they address this problem? So there's two basic kinds of things. They could basically attach vibration and temperature sensors to those machines, which basically was a consistent way to retrofit them to give that sense of, is this machine operating? Are we detecting any problems? Really easy to get some shift KPIs, so people can see who they're on that, working on those lines, exactly what's happening at any one time. Centralized management of those devices and a really consistent approach to it, and then developing some really simple rule-based notifications. So if a problem occurs, what sort of type of problem is it? What sort of person do I need to address to do that? And as a result of that, significantly increase uptime. I think an important point to make is, all of these mentioned strong site and IT security. That has to be without question in all IoT projects. It's absolutely essential that is correct. Another manufacturing company, so Fortune 500 company in about 700 sites. So they wanted to use predictive quality to optimize their processes and really sort of become a leader in sort of having a smart factory. And this touches to another point that was mentioned by Henry before, which is that existing IT solutions were tried by them, and they had lots of solutions from various different vendors with data in lots of different platforms. Really difficult. No common data, no way to compare between them. You know, what could they do? And they had a variety of different machines and tools, so that there was kind of two approaches taken. Some they could connect directly, so they might have protocols like OPC UA, Modbus, or various things, so they could connect those directly to their gateways, pull that data out and push that into AWS. Those could all be centrally provisioned, and all of that data could go into a central data lake. And the second thing is, for those machines where they didn't have that capability, they could just retrofit sensors that might give that same amount of information, maybe not as much detail, but enough detail to achieve what they wanted to do, push that data via exactly the same route into AWS. And that then started to give them the visibility they need to make the decisions they need to sort of improve that process quality. Final one is a pharmaceutical company, so a Fortune 500 company with 40 billion plus of sales. So kind of their vision was condition monitoring and tablet production, and really getting a measure of that OEE/scrap rate so they can long-term optimize and improve. They had an awful lot of automated processes, so any downtime within that was a huge issue for production staff. Kind of the temperature and humidity tolerances they had to measure were quite hard, and they weren't really sure how to do that. And so the solution was kind of retrofitting vibration sensors to sort of measure uptime of the plant, temperature and humidity sensors to really give a sense of, are we within the tolerances we need, and optical sensors to do some of that counting of scrapped material and good material, and really sort of get a picture of that. And it was easily to scale this across all sites. So having done it once, you could just replicate with the same thing across the different sites. And as a result, they could very rapidly react to any of those KPIs that their production staff were seeing, and reduce basically scrap rate from 20% to 8%, which is a huge cost saving. So we talked at the start about some of those blockers that people have to IoT projects, and the first one was kind of security. So we work with CloudRail, who are one of our partners. They make secure gateways, so complete separation of OT and IT networks, if that means anything to you. And we also follow AWS security best practices. We have AWS certified security specialists within our team. And so what we build will be secure, and we can help people understand that and help people understand what they need to basically potentially comply with any of their IT governance requirements that their business might have. We kind of try to have a process that fosters some of that cross-team collaboration between OT, IT, and ops people, and trying to sort of get some of those roadblocks out of the way. It's not always possible. Some companies are harder to work with than others. That's just it. But you know, we can't try and help to do that. We ensure that customers own that data. It's important that they can do what they want with their data. We don't keep it hidden inside away and go, well, you can just get this one view. You can do what you like with it. You can download it all. You can create some new reports. You can run some other AWS tools to get some more information. It's your data ultimately. In terms of kind of support and sort of trying to get some of that internal knowledge, we have a customer success team who work alongside the projects that we run, and we also were able to provide immersion day training to customers. So this gives them detailed AWS training on a range of subjects, which can help them take forward and sort of run projects. And also, obviously, we can support projects, you know, carrying on or however is needed. In terms of sort of that scalability, so most of the solutions we build that are sort of in the manufacturing side, things like IFM sensors, things like CloudRail gateways, AWS services, all of those are inherently scalable, you know, almost on a pay-per-use basis. So kind of if you want to replicate something that you've got here and move it here on another production line or another set of machines, it's incremental costs of sensors, gateways, and AWS services. It's quite easy to scale. In terms of that interoperability, so there's different pieces of equipment and worrying about those sorts of challenges. There are two approaches. There's the retrofit of sensors, where you can't actually connect to an old machine. It's got a really old PLC or something. In fact, also IFM can actually fit PLCs that can then also translate some of that data as well. But also you can connect directly to some PLCs. So some have OPC UA or Modbus or various other protocols, and you can just hoover out that data, push it to AWS. And so that you can get a very high level of interoperability quite quickly. And the final thing is that we you know, Hannah mentioned this, we have package solutions to make it really easy to start. And a typical, shop floor for a very starting use case would be, you might have some modern equipment. Maybe you can connect some protocols to that directly. You might be retrofitting some sensors. Maybe you have several sensors connected to an IO-Link module that'll go to a gateway. Maybe you have some energy monitoring. Maybe you've already got some smart meters that have Modbus, where you can just hook into those directly. Again, that can go into a gateway. All that data can be pushed up to AWS. We can then set up a whole series of dashboards to give KPIs, notifications to people when there are problems. And that's typically a starting point for sort of, those first steps of evolutionary IoT in a manufacturing environment. In terms of the sort of things we offer in terms of fixed price, fixed scope, we do have a solution for asset or energy monitoring. So this is about preventing unplanned downtime. So that pump, fan, motors, all those sorts of things, that real-time monitoring to sort of detect problems and sort of measure that downtime. Or it can be about maximizing energy efficiency, so understanding energy use and taking action to reduce that. A side effect of monitoring energy, if you've got your energy monitoring on your equipment, is you can actually also get a measure of uptime on that equipment as well. And typical approach that we have engaging with customers is to have that an introductory call and a kind of agree up front, what are you trying to achieve and what are the outcomes you're looking for. It's really important to establish that early. What is it that you want to achieve? Because ultimately you want to measure, have you achieved that and have you delivered what the customer needed? And then it's about install and setup, handover and support. And then obviously, we're supporting all the way through that process, and obviously a 3-month review. And, costs include, install sensors, gateways, and 3 months of AWS costs, Cloudwell costs, and our support costs. So that's sort of a typical starting point for an off-the-shelf solution. For something like a custom solution, which might be for maybe it's starting with a very complex machine or something, that would be tailored to our customers' needs. And examples include preventing a failure of very complex pieces of equipment. So some pieces of equipment are not straightforward; they are very complex. Maybe they have many moving parts. Maybe they have different pieces to them. So, talking to a fabric manufacturer recently, and they have some very interesting machines that I've never heard of, stentors and various other things, but fascinating, and they really require a very custom approach. It could be about OE, the full level of OEE for a production line. It could be about getting some of that per unit cost measurement of energy and water usage for a particular product that's being produced. It might be, very specific waste and reduction, and it might be tying with ERP or third-party systems. So in those situations, we kind of split it into 2 phases. We typically have a discovery call, which is an introductory call, arrange a site visit with a partner, IFM, who are experts in sensors. They have about 12,000 sensors. They're able to go in, look at machines and go, yep, you need to put that here, this here, etc. We hold a workshop with the customer to understand, what of these sorts of things are you trying to achieve? What benefit do you need for the business? Do you have any existing baselines, etc. And from that, again, we get to a set of agreed outcomes from which we can then produce a plan of, okay, if you were to move forward, here's a costed plan for how to do that. And that kind of phase, is a discovery phase that costs about 3K. And then we have an implementation phase. And again, that really is dependent on what you're doing. So the complexity of the machine, the level of integration with existing platforms that you have. Typically for a first engagement, it's typically around 20K, and that includes install and setup, handover and support, kind of interim monthly reviews to see what's going, if anything needs tweaking or changing, and then that 3-month review to review against those originally agreed outcomes. That's kind of it from me. So I think I've chatted to most of you, but if that means you want to chat more about anything else, please get in touch. Feel free to book a meeting with us by scanning on those codes, or if you want any more information about some of the solutions we just talked about, scan a code. My email address is there. There are very few Jonathan Custances in the world, so you will find me on LinkedIn. And yeah, be great to chat further. Thanks very much.